Hi everyone, in this lecture we are going to discuss about the fundamental modes of vibrations in polyatomic molecules. The number of modes for a molecule with n atom, non-linear 3n, that is 6 fundamental vibrational modes, and for a linear one 3n, 5 fundamental modes of vibrations. Example, water, which is a non-linear one, it consists of 3 atoms and it can exhibit 3 modes of vibrations, that is symmetric stretch, asymmetric stretch and also bending. And the carbon dioxide is also having 3 atoms but it exhibits 4 modes, that is symmetric stretch because it is IR inactive, and asymmetric stretch active, and 2 degenerative bends. So let us see what it means in the following slides. We can classify the molecular vibrations into stretching and bending vibrations. The stretching vibrations means that the bonds will get either longer or shorter together. So the stretching vibrations can be classified into symmetric and asymmetric stretch. The symmetric stretch means both the bonds will stretch together, that is both the bond lengths will increase or decrease together, and in asymmetric stretch one bond stretches and the other one shrinks. So as you can see, in asymmetric stretching one bond is increasing its bond length, whereas the another atom is decreasing its bond length. So symmetric stretching and asymmetric stretching is all about the bond length, but as in symmetric stretching they are happening together, but whereas in asymmetric stretching if one increases then one shrinks. And then bending vibrations. So bending vibration is all about the bond angles. The bending vibrations can be classified into in-plane bending and out-of-plane bending. In plane bending, the classifications are scissoring and rocking, and out of plane bending, and the classifications are wagging or twisting. So in scissoring means the angles will shrink within the plane, and rocking means the bonds will tilt together. They both are happening within the plane. In out of plane, the wagging means both the bonds move to the one side, while in twisting the bonds move to the opposite ways. So let us discuss in detail about the stretching vibrations. The bond length changes, that is increases or decreases. Stretching requires higher energy than bending and appears at higher frequencies. So these types of vibrations will occur at 4000 to 1500 centimeter inverse. The types are symmetric stretching and asymmetric stretching. In symmetric stretching, both the bonds are increase or decrease in length symmetrically. In asymmetric stretching, one bond length increases while the other decreases. So in case of symmetric stretching, the molecules can exhibit similar type of atoms connected to a core one, whereas in asymmetric stretching 2 different atoms will be connected to a carbon. So they will be having different types of bond lengths. Then bending vibrations. So bending vibrations involve changes in the bond angles. Bending appears at lower frequencies, that is from 1500 to 400 centimeter inverse. Here the bond angle is changing, and they usually occur at lower frequency ranges. The types are in-plane bending, that is bending occurring within the molecular plane, and scissoring and rocking are the 2 types of in-plane bending. In case of scissoring, the bond angle will decrease. So as you can see, in plane scissoring, the bond angles are decreases because both the atoms are moving towards each other. It is like a scissor. So that is why it is called as scissoring. And in rocking, both the bond angles are unchanged, but bonds move in the same direction within the plane. So both the atoms are moving within the plane, but their angles are somewhat changing. So that is called as rocking. It is like a pendulum. Both of them are moving together towards the same direction, but they are actually moving. So they are happening within the plane. So these 2 types are called as in-plane bending. And another type is out of plane bending. So out of plane means this vibration will be happening outside the molecular plane, and they can be classified as wagging and twisting. In case of wagging, both the atoms move to one side of the plane. So in out of plane wagging, both the atoms are moving together to one side, and also that is happening outside of the plane. In case of twisting, one atom moves above the plane while the another moves below the plane. So they both are different. So twisting and wagging are the types of out of plane bending. So this clearly explains that this one molecule will have different types of vibrations. So one molecule can exhibit different types of vibrations, and these different types of vibrations will also have absorbances in the IR region, and dependent on the groups that are attached to the functional groups and also its position, its frequencies will vary and the absorption will also be differing. Thank you.